Hello, we are from Group H and today we will take a closer look at kinematics in one direction for a real-world problem. Without further ado, let's jump straight into it.
So this is our table of contents. As you guys can see, first we'll start with case study background. Second one is objective. Third is theory and formula related. Next, video, question, and lastly is conclusion.
The case study background and topic selection. For the case study, we will be identifying sufficient distance for emergency braking of a scooter. For the main topic, it includes kinematics in one direction. Next, on to the case study background. In the modern world, electric scooters are being used everywhere. However, to prevent accidents or injuries, a few safety measures should be taken. This study shows key factors in influencing the brake distance of a scooter during an emergency braking.
Objectives. Number 1. Determine if the scooter can stop in time to avoid a collision with the obstacle. Number 2. Analyze the consequences of the scooter speed and the distance to the obstacle on the safety of the rider.
The theory in this case will be the acceleration or the rate of change of velocity in this case will be negative, or we call it as deceleration. This happens as the scooter needs to halt before hitting the people in front of him. Halt means that the scooter velocity needs to be reduced from its maximum speed or the initial speed to 0 meter per second. As the scooter needs to be stopped in a short time, the deceleration will be very large. The acceleration and displacement of the scooter can be calculated using the formula below. The first one, v equal to u plus at, or a equal to v minus u over t. The second one, v square equal to u square plus 2as. And the last one, s equal to ut plus half of at square.
So now we will look at question 1. Will the scooter hit the obstacle? If yes, suggest the initial speed to stop the scooter before it hits the obstacle. Information that are given is acceleration, -5 meter per second squared, and initial speed, that is 20 meter per second. So we will use the formula, and that is v squared equal to u squared plus 2as. And then just substitute the information that are given in the formula, and we will get the distance, which is 40 meters. So after that, we have to find the initial speed to make sure the scooter stops before the obstacle. We just use the same formula and substitute the information and the distance that we got before, and we will get 14.4 meters per second. And that's the answer. Okay, next, the question 2. Suggest the deceleration needed in the scooter must not hit the obstacle. Initial velocity is 20 meter per second. Distance between the scooter and the obstacle is 20 meter. So, according to the information that are given, we use the same formula as the question 1, and that is v squared equal to u squared plus 2as, and substitute the information. We will get the acceleration equal to -11.11 meter per second squared. And that's the answer for question 2.
Conclusion. Based on the calculations, if the scooter cannot stop in time, there is a risk of collision with the obstacle. the rider's reaction time and braking ability play crucial roles in avoiding accidents. Understanding the physics of motion and braking distances is essential for safe driving practices. In summary, the scenario highlights the importance of speed control, reaction time, and braking efficiency in ensuring the safety of scooter riders when faced with obstacles on the road.